So today we discuss effect of dielectric on capacitance. So discuss effect of dielectric on capacitance. So what is dielectric? So actually there is a two equipotential surface. Inside these two surface have some dielectric medium. Okay. What type of medium dielectric medium you choose? There's some depending some factor here. So we discuss their factor and what is the effect of dielectric on capacitance. Okay, and capacitance C equal to epsilon naught A over D. So here the main important here the dielectric affecting these epsilon naught factor. Okay, so we know that E electric field 0, that is sigma over epsilon 0. Okay, when the vacuum between these two plates, that is a vacuum. Okay, that is plus plate and minus plate. Here is a vacuum. That is the equation number 1, and there's a potential difference V naught. That is the E naught. V naught, that is equal to E naught times D, and that's the V naught, and D is the separation between two plates or gap between two plates. Okay, so here C naught capacitance, that is equal to Q over V naught, or the Q, that is a plus Q, that is a minus Q, that is the absolute value of Q. Okay, okay, when I put a dielectric between the plates, the surface charge density between the plates are now changed to sigma, and another is the sigma p if I dielectric put. So if we put dielectric between the plates, between the equipotential surface, that is equal to E, that is equal to sigma minus sigma p over epsilon naught. That's the equation number 4. That's the equation number 3. Okay. So now change in potential difference, that is V equal to E times D. That's a basic formula. Now E changes to replaced by these. That is sigma minus sigma naught over epsilon naught times D. That's the equation number 5. Now here we check and the important factor, that is sigma. So here sigma minus sigma p, okay, that is sigma naught minus sigma p, sigma minus sigma p, that is equal to sigma over k. That's the equation number 6, and where k is a constant, and here k value is greater than 1. Okay, so now potential V, okay, that is equal to sigma d over epsilon naught times k. So how to get this value? That is get from here, that is V equal to E times D, and E equal to sigma over epsilon naught. Okay, and that is D, and that is sigma equal to Q by A epsilon naught D. Sorry, that is actually Q. Okay, so finally we get V equal to Q D by A epsilon naught. Not, not, not. Okay, so here I am missing a term A. So finally we get V equal to this, and K value here, K is greater than 1, so that's why K is here. Now change that to equation number 7, and here K is greater than 1, otherwise here is a K equal to 1 here. Okay, now that important another is a C. So C, that is equal to, we know that Q over V. So Q equal to, we get uh, Q, and here the Q put here, the V replaced by this. So by V means A epsilon naught K over Q times D. So that's why these two Q are cancelled. Finally we get A epsilon naught K times D. That's the equation number 8. And you see that equation, and C here, this equation, C equal to epsilon naught A by D, and here C equal to, previously get A epsilon naught or epsilon naught A by D, and here the K here 1, but here K is greater than 1. Okay, so what is that? Means the dielectric K constant is greater than 1, is 1. Now important relation we develop here, that is epsilon, that is equal to epsilon naught times K. Okay, and what is the epsilon naught? Is the permittivity of any medium. That means permittivity of medium. For vacuum, that is equal to K equal to 1, and here epsilon equal to epsilon naught. Okay, so for vacuum here, so K, finally we get epsilon over epsilon naught, and K is the dielectric constant. Now what is the value of K? That's K is called dielectric constant. Dielectric constant, and K is the dielectric constant, and finally we get K, another important K, that is equal to C over C naught. When K is greater than 1, the capacitance increases. The capacitance increases from its vacuum values when the dielectric putting, when we put dielectric fully inserted between the plate or the equipotential surface. Okay. That's the basic concept. What is the factor depending on K? So here we discuss only that when I put a dielectric in between these two equipotential surfaces, so what happened here and what is the change the value of capacitance, and here is a basic discussion here. Okay. Now we discuss another important concept, the combination of capacitor. There is the combination of capacitor, combination of capacitor. There are two types of combination here. Okay, either series or parallel. The series combination and there is a parallel combination. So first we discuss what is the parallel combination. Okay, there is a battery or source. Okay, that is the capacitor 1, another capacitor 2, another capacitor 3. Okay, so that's the potential V, that is a plus minus. Okay, so that is also the V potential here, same value of source battery value. Okay, a source voltage V, and that is same, and that is C1, that is C2, that is a C3. These are the capacitance of that capacitor. Okay, and that C1 capacitor or storage charge Q1. Okay, store charge Q1 means absolute charge. Here Q2, here Q3. Actually, there is a top point with a plus, a bottom point with a minus. Plus here and minus here. Plus here and minus here. But similarity is that the potential difference between these two plates PV, because they are in parallel. So the potential here, that is V, here the potential with a V, here the potential with a V. So their potential be the same actually. Okay, but storing charge capacity is charge Q, that will the change. Okay, so here that is equal to the Q1, that is proportional to V, that is equal to Q1, that is equal to C1 times V. Here that Q2, that is equal to the charge, that is C2 capacitance times V, because the potential be the same here, and that is the Q3, that is equal to C3 times V. Okay, so here the total charge, okay, the total charge of that three capacitor combination of total charge Q total, that is equal to capacitance total. If there is three capacitors the combination here, then the total capacitance of that three combination of capacitor, that is CT times V. Okay, now here these two are equal. Okay, now if they are obey the superposition principle, that is CT times V, that is equal to, means actually get a charge be just added actually. The Q total, that is equal to Q1 plus Q2 plus Q3, and Q2 equal to C total times V, that is C1 V1, C2 V2, sorry, not V1, not V2, C3 times V. Now, if you common V, you get C1 plus C2 plus C3, that is equal to CT times V, cancel these two V. So, total capacitance of the combination of three capacitor in that is a parallel combination, that is a parallel combination, we get a CT equal to C1 plus C2 plus C3. Just we added the capacitance value of the capacitor. The total capacitance of that combination of three capacitor. If a CT, if n number of capacitor connected in parallel, so here C1 plus C2 plus C3 plus Cn. If n number of capacitor are connected in parallel, that is a battery 1, 2, that is 3, and that is here, that is n. Okay, and it is important in symbol, battery one terminal with the long and short terminal with the minus, long terminal plus, short terminal minus. But here the capacitor, the symbol is like two line are equal length. Okay, because you know that is equipotential surface here, these two surface be the same. So that's why in symbolically these two straight line be equal length. Okay, there's a parallel combination of the capacitor. And what is series combination? The series combination is now look like this. The battery, one capacitor, suppose to the three capacitor number 2, here the capacitor number 3. Okay, so here with the positive terminal, with the negative terminal. So here the negative terminal, they create a minus Q charge here, and the minus Q charge, and here that the plus Q charge here. This plus is goes in that direction, and this plus create the opposite polarity here, that is a minus q here, and this minus q goes actually the electron move here to there, that's why get plus q here. If plus q, similarly case a plus q goes here to there and minus q goes here to there, and this charge from that direction get a plus q here, and that is a minus q. Okay, and here this plus charge go minus charge electron and move here to there, so actually electron direction in that direction create a minus charge, and opposite of this created a plus charge, so plus because the loss of electron. Okay, I elaborate again. See the diagram very carefully. Negative. Okay, so electron move in that direction, so that is a negative charge here, and here electron goes here to there, so that means here the plus charge q charge here, and then the absolute value of plus q and minus q be the same. So here the minus q, you give electron move this plate to that plate, and here that is a minus q. Similarly here the plus q means here that electron moves here to there, so if loss of electron this plate get a plus q charge. Here the gain of electron means minus. Similar case, these plus actually electron move here to this plus terminal, so here that loss of electron gains plus. So here that the absolute value of all q be the same. These three are the absolute value be the same. So here that is a V. So change in potential is here. Okay, that is a potential difference between these two surfaces is a V1. Potential difference, that is V2. That is a potential difference is V3. The total is Vt. So similar superposition principle, Vt equal to V1 plus V2 plus V3. Okay, and here see the diagram, that is a Q charge, that is V1, that means a capacitance C1, here the capacitance C2, here the capacitance C3. Okay, that is a Q, that is first capacitor times C1 V1, and here the Q for second capacitor, that is C2 times V2. The capacitor, third capacitor, the C3 capacitance times V3. So here V1 equal to Q by C1, that is equal to V1, Q by C2, that is equal to V2, that is Q by C3, that is equal to V3. So V1 equal to Q by C1, here Q by C2, here Q by C3, and that is Vt, that is a similar same charge store here, obviously Q by total capacitance Ct. We cancel these Q, total capacitance equal to 1 by C1 plus 1 by C2 plus 1 by C3. Clear? If n number of capacitors connected in series, so here Ct, if n number capacitor, that is 1 by C1 plus 1 by C2, 1 by C3, dot 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 1 by Cn. There are two circuit combination of capacitor, series combination, that is a series combination, and upper part we discuss a parallel combination. Okay, clear? So there is a two combination of capacitor, series and parallel. Okay, just basic concept we discuss here. Okay, so next class we discuss what is the dielectric, concept of dielectric. Okay, so here just we discuss only the when dielectric put in between these two equipotential surface, what happened actually, what is the change of capacitance. Okay, we put that concept here, discuss here, when you put a dielectric between these two plates, now what change in capacitance, what is the fact, depending on capacitance or depending on the epsilon or epsilon naught. Okay, in dielectric medium, capacitance are depending on dielectric medium, and what is dielectric, we discuss that what is dielectric in next class. Okay, so today end the class here. Thank you.